I want you guys to remember this. We already learned how to solve a degree 2 quadratic equation by factoring, right? Now we're going to learn how to solve a degree 2 quadratic equation by square roots. So it's the same kind of equation, we're just learning a different way to solve it. Because guys, unfortunately, not all quadratic equations can be solved by factoring. Not all quadratic equations can be solved by square roots either. Only the last method that you learn solves every kind of quadratic, and that's the quadratic formula. All right, but these are just good techniques to have, and then the quadratic formula is something that we can always use in the end. All right, before we solve using square roots, first of all, remember, if you solve a quadratic equation, a degree 2, how many answers are you supposed to get? 2. So guys, when you solve it by factoring, it was easy because it literally factored into 2 factors. You set them equal to 0, and you got 2 answers. You couldn't miss it. The problem with square roots is you kind of have to create the second answer yourself, and you can't forget to do that, all right? So look here, I'm trying to get you ready for this. Here's a quadratic equation. I said x squared has to equal 25. I need you to solve it. I need you to tell me who x could be that would make this equation true. Guys, you know it. Who could you square that would equal 25? 5. That's exactly what you should say. However, that's only one answer. How many answers should a quadratic equation have? 2. Where's the second answer? That means there's another number that when you square it, it also gets you 25. What's the other number? Who else, when you square it, gets you 25? No, we just said 5. Who's the other answer? 25. No, 25 squared is huge. Who else could you times by itself 2 times and it would equal positive 25? Nope, that would be added.
Wait, don't tell us.
You're way overthinking it.
Oh, negative 5?
Negative 5! Negative 5 works too! I could square 5. 5 times 5 is 25. Or I could square negative 5. Negative 5 times negative 5 is 25. So guys, when we're going to be solving using square roots, there's always going to be 2 numbers that when you square them, they get you the same answer. The positive number and the negative number will equal 25. So there's always going to be that positive answer and that negative answer. So in math, the way we actually write that, if 5 or negative 5 could be the answer, we say x could be plus or minus 5. It could be positive or negative 5. So that plus or minus symbol is going to be used a lot in this method and the quadratic formula as well. So you have to remember that there's going to be 2 answers, the positive version and the negative version. So we're going to use that plus or minus symbol a lot to show that we're going to get 2 answers. And I'm telling you, on the first quiz, someone's going to be like, why did I get this wrong? And I'm going to be like, where's your symbol? And you're like, oh, the damn plus or minus. You can't forget this symbol. All right, same thing. If I told you that x squared had to equal 9, solve that quadratic equation. There should be 2 answers. What numbers can you square that will equal 9? 3 and negative 3. There's 2 answers, the positive number or the negative answer. So we would say x could be plus or minus 3. It could be positive or negative 3. So don't forget that. We're going to need that plus or minus symbol today. All right, let's try our notes. Let's try and use these square roots. I know.
Sorry, 24. You know what's funny is 24?
Oh, Bianca, I did get your text. Thank you. I didn't fix it yet, though. Which means if I don't fix it there, you're going to have to remind me again. When I come back, I know I'll put it.
This party?
Yes.
A party here.
Every day's a party in here, Jake.
No, like a pizza party.
A pizza party.
Party without any math.
Whoa, that makes me sad.
The only math
will be like the calories. That's the pizza. You should be ordering. Yeah.
Last year, granted it was COVID, I'd have a lot of people in class. We got talking about dessert, and I make this dessert where it's like crushed up Oreos, and then it's Cool Whip mixed with peanut butter. I don't know if you don't like peanut butter, sorry, you can't be in my life. Cool Whip mixed with peanut butter and confectionate sugar, and you layer that, and then you chop up Reese's peanut butter cups, and you layer them in, and then you make chocolate pudding that you mix with Cool Whip and confectionate sugar. You put that on top, and then you crush up Oreos and sprinkle them on the top.
That sounds
Oh!
You make that without peanut butter.
We made it last year. We had a little party. We all ate it. Oh my God. What? What don't you like in that? Peanut butter? It's Oreos? Do you not like peanut butter?
Peanut butter is food.
You like peanut butter?
No, I do.
You don't like to mix all that? Oh, you don't like sweets? Oh my God, I live for my sweets.
Miss Hardy, so there's one dilemma with this.
What?
People think I do Squidward tentacles, but I do Squilliam.
No, I don't watch that, so I have no idea. All right, we gotta do this stuff.
And it's Squidward, right?
Yes. I am. I started. Thank you. All right, here we go. All right, so we're gonna solve now, guys. We are in section 4.4 now. There is so much that I have to cover in section 4. It's gonna take me a while to get through this section, and I'm trying to break it up into parts. So this is part 1: solving quadratic equations using square roots. Now I put special cases only because, guys, there's only certain quadratic equations that can be solved using square roots. Not every quadratic equation can be solved this way. You can only solve a quadratic equation using square roots if there is no bx term. There's not allowed to be a bx term in the equation if we're going to use square roots. And the reason is, guys, we can have an ax squared term, we can have a c, but we can't have bx because I can take the square root of c. It's a number. We can take the square root of numbers. I can take the square root of an ax squared. Guys, it's a squared term. I'm going to unsquare it. But I can't take the square root of bx. I can't take the square root of just x and know what that's going to get me. Because I can't unsquare just x without knowing who x is. So there's not allowed to be a bx term. So if you're going to use square roots, there cannot be a bx term. All right, so here's our list of steps to solve a quadratic equation using square roots. It's going to feel a little different than factoring. Factoring, we always wanted to get everything on one side, set equal to 0. Here, you want to get whoever's being squared. Either x will be squared or some quantity will be squared. You have to get that alone by itself on one side of the equal sign. So it should feel very much like standard solving equation rules. We're going to add things to the other side. We're going to divide things away. You're trying to get whoever is squared by itself. Then you're going to take the square root of both sides to unsquare it. Since you're taking the square root, there could be 2 possible answers, the plus and the minus, and then you're going to simplify your answers. So fractions always get simplified, and so do square roots. Yesterday we saw how we're always going to simplify our square roots. All right, let's do it. Let's try number 1. Start off real nice and easy. All right, so if I have to solve this quadratic equation, right, 4x, find me the 2 numbers that will make it true. Well, guys, notice. It is a degree 2 equation. The highest exponent on a variable is 2, and there's no bx term. It has an ax squared, it has a c, but there's no bx, so we can use square roots to solve this. So in this problem, x is being squared, so get that by itself. So how do I get negative 16 to move away? Add 16. Now, guys, if anybody looked at this problem, this actually factors. You would be allowed to factor it, but I've asked you to solve it using square roots. All right, so x squared ends up equaling 16. All right, you did it. You got x squared by himself. Now you need to unsquare it. How do we unsquare something in math? Take the square root of both sides, because whatever I do to one side, I have to do to the other. What does a square root do to a square? Cancels. You're just left with x. And now, guys, the minute you take the square root of both sides, how many answers should you be creating? How many numbers could you have squared to get 16? 2. So plus or minus, the minute you take the square root of both sides, you're creating those 2 answers. All right, and now what is the square root of 16? 4. So x could have been positive or negative 4, and it would make this equation true. Go ahead, Derek.
How would you do that?
So you're either going to have on delta math, I believe it's going to have an x equals in front of the answer box, and then they're going to give you a plus or minus symbol. There's a plus or minus symbol on delta math below your answer box somewhere on his keyboard. You can literally put in plus or minus 4 like that, or realize one answer is when x is positive 4, and the second answer is when x is negative 4. So then you could put them in 2 answer boxes if you want. It doesn't matter. It'll mark either one correct, whether you write them as 2 separate or the plus or minus 4 together. Delta math should take either one, Darian. okay? And again, that symbol should be given to you in your Delta Math keyboard. All right, perfect. So guys, it's that easy. So it actually feels nicer than factoring because you're not going through that what times what multiplies to this, what times what gets me the last number, and then what rainbows to the middle. You don't have that thought process to go through. You're literally just getting whatever is squared by itself and then square rooting both sides. All right, let's try it again. Kind of got to get into a rhythm. All right, notice, here's a quadratic equation with an ax squared and a c. There's no bx term. You can use square roots. All right, so guys, but in this problem, and I'm not trying to sound tricky, is x being squared or is x and the 2 being squared? Just the what? Remember, if they wanted the 2 to be included, they would have had to do that, and they didn't. So it's just x who's being squared. So our job is to get him alone. So that means the 2 and the -8 have to go to the other side. Who do you always move away first? The one that's not attached. So add 8. We get 2x squared equals 8. What's the only thing you have left to do to get x squared by itself? Divide by 2. You get x squared equals 4. Now that you have x squared by himself, you can unsquare him by doing what to both sides? Square root. The square root and the square do what to each other? Cancel. What are you left with? X. Now guys, the minute you take the square root of both sides, how many answers should you be getting? Plus or minus, and now what is the square root of 4? 2. So x could be positive 2, and he'll make this equation true, or x could be negative 2, and he would make this equation true. Are you okay? Okay? Yes, go ahead, Paul.
So this is the second method.
This is the second way. The third way to solve a quadratic equation is the quadratic formula. That's section 4.7. That's what we're doing after this. But there is so much to do with this first. This is where imaginary numbers are going to come into play. So we have to learn that first. All right? I know. If you can let go of the fact that it's an imaginary number, and that's just crazy, working with it's very easy. But you kind of just got to let go of the fact that why is it an imaginary number? It has a very real use in math. Like we always say, we, us mathematicians, that if the people who invented the imaginary numbers way back in the day knew how important they were going to be later on in math, they would never would have called them imaginary. They would have thought of a better name so that nobody thought they were imaginary numbers. But either way, here we go. Look here. This is a quadratic equation that does not have a bx term. We can solve it using square roots. So who's being squared? The x and the 1/2 or just the x? The x. We got to get him by himself. So that means the 1/2 and the -28, they got to go. Who goes first? 28. Right? Always the one who's not attached. Let's add him. So we have 1/2 x squared equals what? 10? Now, guys, if this was 2x squared, how would you get x squared by itself? Divide by? So if you still want to divide by a half, have at it. You can divide both sides by a half. I hope you understand that you're trying to figure out how many halves fit into 10. You're not taking half of 10. Yes. Or I would write it in like this. 10 divided by 1/2. Always leave your fraction in parentheses so it stays together.
Wait, what? So it's You don't divide 10 by half.
No, you are dividing 10 by a half, but people think that means you're taking half of 10. You're not taking half of 10. You're trying to figure out how many 1/2s go into 10. 20, right? Because each half takes 2 to make a whole. Wait, or that they do that. Or what we normally try to do to get you to get rid of it is times by his reciprocal. Times the fraction by his reciprocal, and that will get rid of your fraction. You have definitely seen that. We've used that this year. All right, so x squared equals, guys, what's 10 times 2 on top? 20. 1 times 1 is 1, but that's just 20. So do whatever you got to do. Keep, change, flip. You could do divide by a half or just times by the reciprocal.
Divide by half because you don't actually divide by a half.
But you are dividing by a half. When you divide by a half, when you divide by anything, you're trying to see how many of this fit into that. So when you divide by a half, you're trying to figure out how many 1/2s can fit into 10. It just means you're not taking. Don't think 10 divided by a half isn't 5 is what I'm saying. Don't take half of 10. That's not what it means. Timesing by a half means that, but dividing by a half does not. All right, we're getting very philosophical here. All right, so now x squared is by itself. How do you unsquare it? Square root both sides. What happens to a square and a square root? They cancel. And x is equal to. The minute. Go ahead.
You just leave like that?
What?
Square root of 20?
Nope. The minute you take the square root of both sides, how many answers will you be getting? The positive or the negative answer. Now you got to take the square root of 20. Can you take the square root of 20? No. But can you simplify it? There's a number that you can take the square root of, divide evenly into 20. So then I always tell you guys to go off to the side and simplify your radical. Take him off to the side and simplify him. Who's the biggest number you can take a square root of that divides evenly into 20? 4. So we'll break it up into the square root of 4 times the square root of who's left over? 5. What is the square root of 4? 2. And then the square root of 5, you can't take it and you can't simplify it. He is a simplified square root, so he stays. So now your answer is plus or minus 2 times the square root of 5. And guys, all that is a very ugly decimal. 2 times the square root of 5 is an irrational number. It is a decimal that never ends and never repeats. So we don't want you to write that as your answer because you would have to round it and then you lose accuracy. So this is the most simplified and exact answer you could give me. So one answer is positive 2 times the square root of 5, an ugly decimal. And the other answer is negative 2 times the square root of 5, which is another very ugly decimal. All right, so you're not going to get the prettiest answers here. And this means that this would not be solvable by factoring, since look who your answers are, 2 times the square root of 5. You would not be able to factor that nicely. All right, one more like this.
What idea was it to add letters into math?
Letters into math, I know. Guys, but just can you imagine that where all this came from, right? People did all this back in the day, and all the people that came up with these math concepts, they never had a calculator.
That's insane.
When they took the square root of 5, they literally had to use like a sheet of paper to figure out what that would be. And just work out the numbers. I mean, it's crazy. The people that invented all this stuff didn't have any of our technology, and they were able to create it. It's just beautiful.
Yeah,
because they needed to. They needed to have methods in the world that work, plotting lands and stuff like that.
Like all of a sudden we need to know the square root.
Yeah. Because it all goes back to probably creating and plotting lands that people were buying. Yes, Chris.
Is it the Romans or no?
Romans and it's like Babylonians. They play a huge role. Now, a lot of in Europe, that's where we all came from. Basically, just these unbelievably smart people, like crazy. All right, here we go. So that is a quadratic equation that has an ax squared and numbers. No bx term. We can use square roots. So in this problem, x is being squared. Let's get them alone. Who goes away first? No. Who has a just x? He's a just number. He's a just number. He's an ax squared. There's no bx term here. So who's going to move away first? The -8 or the -3? Always the one that's not attached. So add 8. And you're going to get -3 x squared equals -2. What's the only thing you have left to do? Divide by -3. Uh-oh. And you're going to get x squared equals, what's a negative over a negative reduced to? 2 doesn't divide by 3 and it doesn't reduce, so 2/3. Okay, now x squared is alone. How do you unsquare it? Square root both sides. So now you have to take the square root of a fraction. All right, so what happens to a square root and a square? They cancel. X is equal to. The minute you take the square root of both sides, how many answers are you going to get? Plus or minus. Now here's the problem. You have to take the square root of 2/3. 2 doesn't divide by 3, it doesn't reduce to a smaller fraction. We're not getting anywhere as the square root of 2/3. So let's take this off to the side. Let's split it. Give the top and the bottom their own square root, and we will deal with this one square root at a time. So we're going to get the square root of 2 over the square root of 3, right? We're just splitting it into their own square roots. All right, go to the top first. Can you take the square root of 2? No. Can you simplify? No, great. Can you take the square root of 3?
No.
Does he simplify? Wonderful. So it's like, all right, good, I'm done. I wish. Math says you are not allowed to leave an irrational number, the square root of 3, a very ugly decimal, as your divisor in the denominator. So we have to get the radical out of our denominator. Who did we learn we can times the square root of 3 by to make his radical go away? Itself. So we're going to times the bottom by itself, the square root of 3. But then math also says whatever you do to the bottom of a fraction, you have to do to the top. So we're going to times the top by the square root of 3 as well. All right, on top, the square root of 2 times the square root of 3 becomes the square root of, what is 2 times 3? 6, over. On bottom, you're going to get the square root of 3 times the square root of 3, which is the square root of 9. And who's the square root of 9? Just 3. So it becomes the square root of 6 divided by 3. The whole point of doing that was so that the bottom didn't have a square root anymore. All right, now, before we say he's our answer, go back up top. Can you take the square root of 6? Can you simplify the square root of 6? So we're good. That's okay. Nothing else simplifies. We are done. It is the positive or negative square root of 6 divided by 3. And that is your simplified exact answer. So guys, one answer by itself is the square root of 6 divided by 3. And then the second answer is basically, think of it as negative 1 times the square root of 6 divided by 3. They're just very ugly decimals, and we don't want to write them as our answer. All right? Or you could just leave it as the two answers together.
That was literally the most insane thing I've ever seen done in math.
Okay. Those are as easy as the problems we're going to get. So now look at the next. I'm trying to prepare you for all questions that you could see with a square root.
No way.
Oh, yeah. All right, so look at example 5. This is part 2.
Why don't you? Oh, that's here.
Okay.
Right.
So this one, it's not much different. You still have to get whoever's being squared by itself. The problem is, x is being squared, but where is he right now? Where is he stuck? In the parentheses. So if your brain immediately said, I'll distribute, I'll combine like terms, I'll solve, then we have trained you properly. That's exactly what you should be thinking. I got to get them out of there. I got to get rid of parentheses. However, let me try to give you a shortcut to that may help with the next kind of question you have to do. Right now, I'm trying to get x squared alone so I can take his square root. So without worrying about distributing, don't worry about this part. This 5 has nothing to do with the distribution or anything. So how could I get him away right now if I wanted to? I could move him. All right, let's minus 5.
Sorry.
Yes.
I'm sorry I took so long.
Uh-huh.
There was a kid in the bathroom.
Uh-oh.
He might, he was like a little bit like.
Is he all right?
No, he was like special.
Is he okay?
No, yeah, he's
Was he
fine.
having trouble or?
No.
What are you getting at?
He was like telling me how to make colors.
Well, maybe he wants you to know. All right, so Jake, this is good. This is a good problem to see. So now we look here. So now, if you're thinking, okay, Hardy, now I'll distribute. You could totally distribute. Or instead of distributing, if this is timesing by 5, what operation would undo that? Divide by 5. Guys, you can divide it away right now. And you would never have to distribute him in. And then you'd be left with x squared minus 6 equals what's 0 divided by 5? 0. Now, if you're thinking, I don't know about that, Hardy, then that's fine, guys. You could distribute, combine like terms, and move everything away. I guarantee you end up with the exact same answer as here. All right, so now, what's the only thing I have to do to get x squared by himself? Add 6.
X squared equals 6.
Okay.
Miss Hardy, we do that every time.
Yes. Now, see, the problem is before, normally we were dealing with either not an equation, an expression, and then you'd have to distribute to combine like terms. But if it's an equation, then yeah, you could always do that. All right. Now, we're here. Yes.
I have a question.
Yes.
So why don't we do that all the time?
Because sometimes you're going to create fractions, and you might not want to do that. I've given you a problem that it nicely works for. It would work.
How would we know if it actually nicely worked like from the beginning?
You'd have to go through the process.
Golly.
Right? Now again, a lot of times when you had to distribute, you were simplifying an expression. Then you'd have to distribute. You wouldn't be allowed to move things away to the other side of the equal sign because there's no equal sign. So a lot of times with the distributive property, you're only working with an expression, not an equation. All right, here we go. We're here. How do I unsquare it? Square root of both sides. Square root of both sides. The square and the square root cancel. I'm left with just x. The minute you take the square root of both sides, how many answers should you be getting? Plus or minus? Now here's the good news. Can you take the square root of 6? Does he simplify? Then you leave it the square root of 6. So now one answer is the positive square root of 6, which is just a very ugly decimal, 2 point something. And then the next answer is negative 1 times the square root of 6, which is just a very ugly decimal.
Wait, what?
So we need to wait. That's
So you can leave it like this, or you can break it up into 2 separate
No,
answers.
so you said you can simplify it, so I thought we were gonna simplify it to like 3.
But whoa. Let's say you did.
we can't. It's not.
Can you take the square root of either of those numbers?
No.
No, so there's no point in splitting him. He has no perfect squares. He is a simplified square root.
Oh,
That's why we get to leave him. What's up? Yeah.
Oh,
He doesn't simplify. Nothing divides evenly into him that you can take a square root of.
and that's why leaving
This
number 3 is 20 before that would be
was not okay because 4 divides evenly into 20. You can get a number that you can take a square root of out of him. There's no number that we're going to be able, even if I broke it up into 6 and 1, yeah, the square root of 1 is 1, but you're still left with the square root of 6. So there's no point in splitting him up because no perfect squares divide evenly into him.
like 8. You'd have to.
You'd have to because 4. But 10, you leave 10 because nothing divides evenly into 10 that you can take a square root of. All right, here we go.
Mind-boggling.
Right? Math is just beautiful. All right, let's try it. Let's try it one more time before we see the last type of problem. So now you see how, again, it's x squared. He's stuck inside those parentheses. If you want to distribute and combine like terms and get, that's fine. Or, right now, this has nothing to do with it, so how could I get the 9 away? Minus 9. Then you get 4.
Then you divide.
Okay, Jay, wait for me.
I'm just
All right. What is the, now you could distribute 4, or you could get rid of it now by dividing it away.
Yeah.
And then you are left with x squared minus 3 equals 5. Keep going. How do you get x squared by itself? Jake, how come you don't do your homework? You clearly know how to do this.
What's x squared?
How do you unsquare it now? Square root.
Square root.
What does a square root and a square do? Cancel.
Each other out.
X is equal to, the minute you take the square root, how many answers are you getting?
2.
Plus or minus. Now, can you take the square root of 8?
No.
But can you simplify him?
Yes.
Yes, because there's a number that you can take a square root of that lives inside of 8. So I would just take it off to the side. And what number divides evenly into 8?
4.
So we'll break it up into the square root of 4 times the square root of, who's the leftover? 2. What is the square root of 4? 2, and then the square root of 2 is a simplified square root, so he stays. So your answer is the positive or negative 2 times the square root of 2. That's your simplified answer.
Did you see that cat?
So you did, yes I did. So one answer is 2 times the square root of 2, and one answer is negative 2 times the square root of 2, and they're just very ugly decimals. No.
Not bad.
All right, last one, and these are the ones that blow your mind.
Miss Hardy.
What's up?
Can I leave 5 minutes early so I can walk my friend to get his 2 bones like
Where?
like to the car?
He doesn't have somebody from his class doing it?
Nah, he had to like tell the office.
If he needs you to do that, Jake, that's fine, but just know you've basically saw nothing from today.
Hey, come on, Jake.
All right, here we go. Now, even though you do sound like you know what you're doing.
See?
These ones are different because is x the only thing squared right now? No, right now you have a quantity squared. That's okay, guys. Your job is to get whatever is being squared alone. So if this entire quantity, if this entire parenthesis is being squared, then get that alone. Then get this 3 and get this negative 20 away. Who goes first? Negative 20. We add it.
It is a quantity squared.
Right. So now we have 3 times x plus 2, the quantity squared, equals 27. Now here's where I tried to get you guys in this mindset in the previous examples, because here you are not allowed to distribute. If you're thinking like, all right, guys, you're not allowed to distribute first here, because this is squared. And PEMDAS clearly says we have to square something before we multiply it by 3. So you wouldn't be allowed to distribute here. You have to divide the 3. You are not allowed to distribute it here. It has to get divided away. All right, so we can divide the 3 away. And then you're going to be left with the quantity x plus 2 squared equals 9. Guys, you did it. You got what was being squared alone. This whole parenthesis is being squared. So how do I unsquare it? Take the square root of it. So take the square root, you're right, of both sides. What does this square root do to that square? What are you left with? X plus 2. So normally, when you take the square root, x is alone. X isn't alone here because he's not the only thing that was being squared. So we have x plus 2 left equals, guys, this is going to get weird. The minute you take the square root of both sides, how many answers do you get? Plus or minus. So now you have this plus or minus 3 in the middle of a problem that isn't finished. But keep going. You have one more thing to get x by itself. How do I get x by itself? Subtract 2. But when you subtract 2, it's like, wait a minute. Who am I subtracting 2 from? The positive 3 or the negative 3? Both. No, you're not. You're not going to get the same answer. You're going to do it from both. But what I want you to do first is we're going to write this. Take the negative 2, whoever you moved over, I want you to shove it in front of the plus or minus sign. So your answer is going to say this. This will just help us get organized. See it? All right, negative 2 goes in front, and then it'll be plus or minus 3. We can do this. We can work out both of these scenarios. One answer is going to be what we get when we take negative 2 and add it with 3. And then the second answer is going to be what we get when we take negative 2 and subtract 3. We're literally going to play out both scenarios. If this was a plus 3 and if this was a minus 3. So guys, what would x end up being if we took negative 2 and we added it with 3? 1. X would be 1. That's one answer. But what would we get for x if we took negative 2 and subtracted 3? Negative 5 is your second answer. Now, this one only played out so nicely because 9 was a perfect square. We were able to get rid of that square root, and we were left with this beautiful plus or minus 3. It doesn't always happen like that. Go ahead.
I need to turn this up. But what would have happened, right?
Mm-hmm.
If I had went all this, right? So 3, that. From there, I went like this and got that. And
we got that.
And then I turned it into this.
Yep.
No way.
If you do this, you're going to get x squared plus 2x plus 2x plus 4. You're going to create a standard form of a quadratic equation. You're going to create a bx term that we're not allowed to solve by square roots anymore. You can do that. I think you're wasting your time. You're going to turn it into a problem that either has to be factored, or you're going to turn it into a problem that has to be solved by the square root of the quadratic formula.
It's 48.
All right. Guys, I really would like to have done the last problem, but I think at this point I would just be rushing it. So there is a homework assignment on Delta Math on this. I write down habit closing tomorrow at 11:45 like a normal homework. I'm going to extend the due date. I'm going to leave the homework on this open until the Wednesday when I come back at night. Just God forbid you have questions. I think I owe it to you to at least leave it open long enough to where you would be allowed to ask me a question when I'm back on Wednesday and then fix anything before it's due that night. If you can get it done before that, I think you should. But if you have any questions, I am going to leave it open. Go ahead. I don't know.